Hello viewers on YouTube. In this video tutorial, I kind of want to show you how the formula we used to simplify the difference of 2 cubes was actually derived. We know that according to the formula, it says that when you have a difference of 2 cubes like a to the power of 3 minus b to the power of 3, then this is the same as a minus b, then multiply by a squared plus ab, then plus b squared. Right, perfect. Now our goal is to actually prove this out, is to show how these was actually derived. Okay, so to do that, let's consider a binomial all to the power of 3 whose n value is 3. That's a minus b all to the power of 3. Excellent. Now we know that to expand this binomial, this is the same as having a minus b and multiply by a minus b all squared. Excellent. So first, let's expand this one and then distribute it to this and see what we got. So what exactly is the expansion of a minus b all squared? For that to also be, for it to be simple, let's split it into 2 as well. So this is the same as a minus b, then a minus b, again a minus b. Perfect. So let's pay attention to this first, and then we now move to the next one. So we have a minus b. So expanding this, we have a times a, that gives us a squared. Then a times minus b, that's simply negative ab. So negative b times a is the same thing as negative ab as well, as the order doesn't mean anything. Then minus b times minus b is simply positive b squared. Now to simplify more forward, let's try and see if we can add like terms. So we have a minus b, again multiply by a squared, and these are like terms, they are addable. So minus ab is simply minus 2ab. Then we have plus b all squared. Perfect. So our goal now is to actually expand the two expressions. Okay, to expand that, we will take each of these and then distribute it to each value right there. Okay, perfect. So now a times a squared, that's simply a to the power of 3. Then a times negative 2ab, that would give us negative 2a squared b. Then a times positive b squared, which gives us positive ab squared. Now minus b times a squared is simply minus a squared b. We can write like that. Then minus b times minus 2ab is simply positive 2ab squared. And finally, minus b times positive b squared gives us negative b to the power of 3. Excellent. So now at this point, let's try and get rid of this, because we have the space. But don't forget, what we have at the left hand side is still what it's equal to everything we're having right here. Perfect. So this is equal to, let's try and add like down. So we have a to the power of 3. So what I would like to do is to bring b to the power of 3 next to a to the power of 3. So that's minus b to the power of 3. Now we have negative 2ab and negative 2a squared b and negative a squared b. And if we add them together, we would have negative 3a squared b. Now for positive ab squared and plus 2ab squared, that will be positive 3ab squared. Perfect. Now since our goal is to actually isolate the difference between these two cubes, we can actually bring these two expressions right to the left, or yes, to the left hand side, and then we have a minus b all to the power of 3 plus, when this comes, actually it becomes positive, plus 3a squared b, and when this comes all the way to the other side, it becomes negative 3ab squared, and this is equal to a cube minus b cube. Perfect. So right now what we are going to consider doing is to see if we can actually simplify and factor out any common factors. Okay, let's first of all actually simplify this a little bit. What is common actually? What do you think is common between this term and this term? Notice that 3 is in both sides, or is in both terms. To say it makes sense, a is also in both terms, b is also in both terms. So we can actually select 3ab as a common factor. Then we have a minus b all to the power of 3 plus 3ab in the bracket. For this term, what are we going to have left over? Taking 3ab out of 3a squared b would we would have left over just a. Then we have the subtraction sign. Then what about this? It's simply b. So we'll be left over with b, and this will be equal to a cube minus b all cube. Now you can see that a minus b all cube is here, and it's also here. So you can see this as 1 a minus b all cube. So you can still take a minus b all cube, a minus b alone as a greatest common factor. So taking it out, we have a minus b outside. Then we have a big bracket. This is just 1 a minus b squared. You're taking a minus b away from a minus b all cube. We will be left over with a minus b all squared. Then this will be just plus 3ab. That will be plus 3ab. Excellent. Am I communicating? I hope you are not lost yet. Okay, so we took out the common GCF, which is a minus b. Alright, taking a minus b for this term, we'll be left with just a minus b squared, which is what we have written down here. And for the other term, we will be left with just 3ab because we have taken a minus b away from it. And don't forget, this is equal to a cube minus b all cube. Okay, since we're out of space, let's get it on stops. Excellent. So right now, what we are going to consider doing next is to expand this one. Okay, so now we have a cube minus b cube to be equals to, in the bracket, a minus b. So for the big bracket, let's expand this a minus b squared. I think we did that earlier. If you could recall, that's simply a squared minus 2ab then plus b squared. Excellent. And don't forget, we are adding it to this one, which is plus 3ab, and we'll close the bracket. Now simplifying more forward to the least term, we have a squared. Now these are like terms, minus 2ab plus 3ab. So adding them up, we'll be left over with plus ab plus b squared, which actually corresponds to the formula we often use in our algebra and calculus. And that's how the simplification of difference of 2 cube was actually derived. I hope you find this helpful and understandable. I want to believe by now you know where the formula actually came from. Thanks for watching. See you in the next video. Bye for now.